we'll start with the class right now. So, guys, welcome to NEET World Institute and NEET World YouTube channel. So, in this class, we are going to discuss about this questionnaire of the thermal properties of matter. As we have completed our the topics, right, and we have seen some of the questions in the conduction part, and before that conductivity, everything like. Everything we have seen, and we'll see some more question in this class. Okay, so let's go with the questionnaire part, right? So let's take the questions and go see the question, analyze the question slowly, and we'll go one by one. Okay, yes, where I kept the things. Yes, the first question: a pan filled with, wait a minute, I guess you're not getting the measures right. Yeah, so pan filled with hot food cools from 94 degrees Celsius. 94 degrees Celsius, keep this point. There is a hot food, guys. Hot food is there, and it has been cooled from 94 degrees Celsius to 86 degrees Celsius in 2 minutes. 2 minutes. Okay, the time they have given as T is equals to 2 minutes, and the temperature 94 degrees Celsius to 86 degrees Celsius. So what is the change in temperature we can take? 94 minus 86, right now. So how much it is? Yes, how much it is? So 4 and 4, 8, right now. 8 degrees Celsius now. Got it? Okay. When the room temperature is at, they have given room temperature is at 20 degrees Celsius. 20 degrees Celsius. How long will it take to cool from 71 degrees Celsius to 69 degrees Celsius? Okay, fine. They have given the time for this temperature. I need to find the time for this temperature. Okay, so start. The time starts now. 1 minute time is there. We'll see who is going to give the answer for this question first. Done? I guess time is up. So we'll see the answer for this question now. Right? See, if you see here, the average temperature of 94 degrees Celsius, okay, and 86 degrees Celsius, if you see it's 90. So how we have taken 94 plus 86? So it is 0, 190, 190, right? Yes, 180. So 180, and the average they are taking. So it is 90. Similarly, this is 71 and 69, so 140, and we will get it as 70 degrees Celsius. Okay, fine, that one is fine. And what about the thing like changing temperature divided by the time is equals to K into delta T. K into delta T, which is nothing but we will take 94 minus 86 divided by 2 will be equals to, like, why we are taking 2 minutes. Okay, so 8 degree by 2 will be equals to K into 70 degrees Celsius. Like the room temperature they are asking now. So we are taking the average temperature and the room temperature, we are subtracting it out. Okay, and we will take this and this equation number 1 and this is equation number 2. So when we talk about this 71 and 69, right, 71 minus 69 is 2, so 2 divided by the time, I need to find the time, right, and K into 70 minus 20. here if we take the ratios, right, so 8 by 2 divided by 2 by t will be equals to k into 70 divided by k into 50. K cancel, 0 0 cancel, and cross multiply it. How much we will get? 8 in 8 divided by 2 into 5 will be equals to 7 into 2 divided by t. Right, no? So 8 5 are 40 na? And this is 4 times. So 20 into t will be equals to 14. T will be equals to 14 divided by 20. 14 divided by 20, and this is 1 time, sorry, okay, 7 times, and this is 10 times, this is 0.7 minutes. So we are calculating in minutes, right? So 0.7 minutes, right? So when we are calculating it 0.7 minutes into seconds, we are calculating 0.7 into 60. So we will get 0 0, we can cancel off 42 seconds. So it will take 42 seconds to cool from 71 to 69 degrees Celsius. Cool from 71 degrees Celsius to 69 degrees Celsius. Got it? Fine. Okay, we'll go for the next question. Okay guys, let me take this question a little bit serious, okay? Yeah, I guess the question is clear now. A 10 gram of ice at 0 degrees Celsius is kept in a calorimeter. Okay, so here is the thing, it's going to be started. So calorimeter in the sense what we should do. So heat gain is equals to heat loss. Remember this point whenever they are asking about the calorimeter, okay? So calorimeter of a water equivalent 10 gram, water equivalent 10 gram. How much heat should be supplied to the apparatus to evaporate the water thus formed? So they neglect the heat loss. They have given that we should neglect the heat loss, and the options are given 6200, 7200, 13600 and 8200 calories. Okay, and yes, your time starts now. Solid 1 minute time is there for you guys to answer this question. Yes. So if we talk about the 10 gram ice at 0 degree Celsius, no, is placed in a calorimeter with equivalent water they have given, that is 10 gram. Fine. To evaporate the 10 gram of water, we must do like 10 gram of ice, na? So 10 into 80, like what is the formula? What is the formula? ml. Q is equals to ml. Right? So latent heat, right now? So mass we know, latent heat we know, that is 80. So the Q is 800 calories. Okay, fine. Heat the 10 gram of water from 0 to 100 degrees Celsius. What is the thing they are asking? See guys, it is ice, no? Ice. Okay. To melt that ice into water, this much calories it is needed. Again from 0 degree to 100 degree Celsius, like I need the other heat to take that water into a boiling point stage to evaporate it. Na? So 10 into 1 into 100. What is the meaning of 10 into 1 into 100? Ms delta T. Got it? Got the point? Heat the calorimeter from 0 degree to 100 degree Celsius. Again we are having 1000 calories. Got it? So evaporate 10 gram of water from 100 degree Celsius. Evaporating it again. Latent heat of fusion, latent heat of vaporization. We are using both. So 1, 2, 3, 4. Why we are taking the third point? The calorimeter we are measuring, right? That's also we should use, na? So that's why. So 5400. So now if you talk about 800 plus 1000, 1800 plus 1000, it is 2800 plus 5400. So we will get as 8200 calories. That is the answer. Whoever got 8200, 1000 calories, that's the correct answer. Option 4 is the correct answer. Once you can take a look of this question and we can go for the next question. I guess hope it's clear right now. The next question, if you see, okay, I hope the question is clear now. How many gram of ice at minus 20 degrees? Okay, minus 20 degrees Celsius are needed to cool 200 gram of water from 25 to 10 degrees Celsius. So again, what's the thing happening here? How many gram of ice? How many gram of ice at minus 20 degrees Celsius are needed? So we need to find the mass. We need to find the mass. That's the question. Try to understand the question. And if you see, yes, if you see here, like they have given 200 gram of water and it's from 25 degrees Celsius to 10 degrees Celsius, which means heat has been getting lost, right? Heat is getting lost. Heat lost, right? So again, 1 minute time and let's start with this question. First. Who is going to give answer for this question? Option 1, 2, 3, 4. It's 20 gram, 30 gram, 40 gram or 50 gram. Which is the correct answer? Last 10 seconds. Last 10 seconds time. Okay. I guess which option? Option number 2, 3. Okay, we'll see. So first we'll see which is the option. Yes, option 2, whatever you guys have told, it's correct answer. Fine. And let's check with this, okay? And guys, like whoever told option 3, please try to understand which point you have made wrong, okay? Okay? So okay, fine. 200 gram of water we have taken, and which is from 25 degree to 10 degree Celsius. We need to cool it, right? Like in the sense like heat is getting lost, right? So heat lost. Okay, so heat lost is nothing but it is same. Like is there anything like the state has been changed? No, right? Like state is remains constant. Like 25 to 10 only. Like it's a So what we should do now? So we should consider that is a same state, and we need to apply the formula Q is equal to ms delta T. So Q is equal to ms delta T. And what is mass? That is 200 gram. And what is specific heat of water? It is 1. And how much it has been changed? So it is 15 degree. Na? So 200 into 1 into 15. So answer we will get as 3000 calories. Fine. So we should not stop up to this. We need to carry on, right? No. So let m be the mass of ice at minus 20 degrees Celsius. Like heat absorbed by this ice reaches the final temperature 10 degrees Celsius. Why sir? We are taking 10 degrees Celsius. See, we are considering the water from 25 to 10 only. No, that's why we are considering that reaches the final 10 degrees Celsius. Fine. So warm ice, that is minus 20 degrees Celsius to 0 degrees Celsius. First we will keep, then 0 degrees Celsius, then 0 to 10 degrees Celsius. First what we need to do? Minus 20 to 0, then 0, then 0 to 10. So three things we need to calculate. 1, 2, 3. Here if you see, here, okay, what is the thing? The thing is ms delta T we can use. Here the state is getting changed. Here the same state. Okay, so the formula m into s into delta T, right? So m into 0.5 into 20. How much temperature has been changed? 20. So m into 10 calories. Okay, and if you see about the ice melt at 0 degrees Celsius, so again here the state has been getting changed, right? So m into 80 calories, and we'll take this and we'll add together, and we will equate to this right now. If you see next thing, warm water melted from 0 to 10 degrees Celsius, m into 1 into 10, like mass into specific heat of water into the changing temperature 0 to 10, 10 minus 0 is 10, so m into 10 calories. So if you combine this thing, no, m I can take commonly outside, so 10 plus 80 plus 10 will be equals to how much? So here 3000 calories now. So 3000 calories actually equated. So m into this is 100 will be equal to 3000, and two zeros will get cancelled. M is nothing but 30 gram. So option 2 is the correct answer. Option 2 is the correct answer for this question. Got it? So this is how the question will be. This is how the questions will be. And we go for the next question. Here we go for next question. Okay. So the next question, if you see, yeah, first let me take this question to the okay. I'll give one question. Similar question only. Similar question. I'm repeating the term similar question to the last two questions. Okay. So 100 gram of ice at a 0 degree Celsius is mixed with 300 gram of water. So ice mixed with water. Okay. Specific heat of 1 calories and at 80 degrees Celsius. Fine. So ice is 100 gram of ice is at 0 degrees Celsius. 300 gram of water is at 80 degrees Celsius. The final temperature of the mixture will be. That's the question here. Okay. So it's a similar type question. We have a solid 1 minute time for this question. Solid 1 minute time. equals to 100 gram at 0 degree Celsius, latent heat of fusion, and water specifically. This is the 2 point we can understand here, right now. So at 0 degree Celsius, if they are saying no, at 0 degree Celsius, the state is getting changed. Okay, fine. So Q is melting, M into L, that is 100 into 80. And like if you talk about the water at 80 degrees Celsius, no, like 300 is the mass and specific heat is 1 and 80 is the changing temperature. So total how much? Like if you talk about this and this, it is 32, but the thing is Q hot is greater than Q melt. All the ice will melt and the remaining heat after 24,000 minus 8,000, which is nothing but 16,000 calories. Okay, that's where you have got the mistake. Everyone have taken 32,000. Why? It's not like that. Here the twist is Q hot and Q melt. If I talk about this thing and if I keep in the Q hot, no, obviously the temperature will get reduced and the calories also will get reduced, right? So 24,000 minus 8,000 will give 16,000 calories. This remaining heat raises the temperature of the mixture, and total mass of a water after melting is 100 plus 300, no? So 300 and the 100, so 400. So what is the formula? Q is equals to mc delta T, where I need to find delta T. So delta T will be equals to Q divided by M into C. And what is Q? So 16,000 divided by what is M? Mass, it is 400 and into 1. So 2 zeros and 2 zeros, 1 times and this is 4 times. Answer is 40. So 40. Yes? Got it? Answer is 40. Yes. So the next question we will see. Yeah. So a liquid of a mass M and a specific heat C is released to a temperature 2T. Another liquid of mass M by 2. Here the mass is M and specific heat is C they have given. Here M by 2 and specific heat is 2C. Is heated to a temperature T. If these two liquids are mixed, the resulting temperature. So mixed in the sense, what is the thing we should do? MC delta T is the equation we know. M1C1 TH minus T mixture with equals to M2C2 T mixture minus T cool, like temperature cool, right now? Cold, right? M1 how much mass M they have given, C, and heated to a temperature 2T minus T mixture, and they're asking the mixture temperature now. Okay, will be equals to, this is M by 2 and this is 2C and this is T mixture minus how much T? This is TC is T. MC will get cancelled, 2 also will get cancelled. 2T minus Tm will be equals to Tm minus T. And this temperature of mixture we can take to the one side and the remaining temperature we can take other side. 3T will be equals to 2Tm and temperature of mixture will be equals to 3 by 2 times of T. 3 by 2 times of T, option 4, 3 by 2 times of T. That's the thing they have given here. I have explained it clearly, right? This is the thing. I guess it's clear. I guess it's clear. Done? Okay. So I'll give a homework question for you guys. The value of coefficient of volume expansion is simple question. Volume expansion of glycerin is, so volume expansion in the sense alpha, beta, gamma. Gamma is the volume expansion 5 into 10 power minus 4. Okay. The fractional change in density of a glycerin for a rise of temperature 40 degrees Celsius in its temperature. Guys, listen one thing carefully. We know that the density is equals to mass by volume. Density equals to mass by volume. And mass doesn't change, will keep as it is. when we talk about mass, I'll keep as it is, density is inversely proportional to volume, volume will be inversely proportional to density, right? We should consider this in terms of density, in terms of volume, and we need to proceed with the formula. Delta V by V is equals to gamma delta T, gamma delta T, right? So gamma value they are given directly, and temperature also they are given directly. So what else we need? So can we multiply the things directly here, right? If you talk about this, I can take V is equals to rho power minus 1, delta V by V is equals to minus 1 into delta rho by rho. Okay, keep that minus as it is. If you talk about that one, okay, delta V is equal to, delta V by V is equal to delta rho by rho. Fine. And if we see here, 5 into 10 power minus 4 into 40. So 5 into 4 is 20, and this 0 into 10 power minus 4. So 200 divided by 2 zeros and 2 zeros. 2 zeros, 2 zeros will get cancelled off, and the remaining is 0.02. That's it. Right now, 0.02. What is the answer now? Option B. I have only done the equation. No homework. Yes, I have done the equation, right? Okay. So is it understand the questions which we have done? So I'll bring some more questions in the upcoming session. Okay.